Let's try and solve this logarithmic equation. So we have log base 5 of 125 equals x. Okay. So if you want to have a go at solving this one by yourself, feel free to pause the video and have a go. But let's get straight to it. Okay. So obviously it's actually already solved. This is equaling x, so that's the correct answer. Bye bye. We've got to simplify this a bit pretty much, okay? So we have to think of, all right, 125 can be represented as 5 to the power of something because you want to simplify this log. So they wouldn't have done this if you couldn't do this. So first of all, let's try and think of a couple of things, okay? So 5 to the power of 1, that's 5. 5 to the power of 2 is 25. But when you get 5 to the power of 3, that's 25 times by 5. Now, I'm not mistaken, that should be 125, but if you aren't sure, you can just double check using multiplication. So 25 times by 5, and you'll get, so 5 times 5 gives you 25, and then 2 times by 5 gives you 10, and then you just add them together, so you get 5, 2, and 125, okay? So that means you can represent 125 is equal to 5 to the power of 3, okay? So we can then substitute this fella into this equation here just to simplify our working and break down the log even further, okay? So let's just move this guy out of the way. That can go over there. So we can go log base 5 to the power of 3 is equal to x. Now what we can do using our log laws is we can take any power outside the log and move it to the front. So this can be rewritten as 3 log 5 of 5 is equal to x. Now, if you're logging something and this is the same number, this is the same as 1, okay? So you technically have 3 times by 1 equaling x, so the correct answer, x is equal to 3. And that's it. Let's take a look at the next one, okay? So the next one will be a little bit harder. Let's go with log 4 of x minus 1 plus 2 is equal to log 4 of x plus 4, okay? So what we can do in this example here, well, before anything, if you want to have a go at solving this, feel free to pause the video and solve it, and then let's just get straight to it. So what we want to do is combine our logs together, okay? So the easiest thing to do would actually be moving this guy over to this side here, rather than making that negative and moving that across and having that equal to 0, okay? So what we're going to do basically is just minus that from both sides, so minus log base 4 of x minus 1 and minus log base 4 of x minus 1. Because when you're solving log equations, you want to group the logs together and any number on one side. If it looks difficult, that's the go-to way to solve logs, okay? Because then you can just start using some other rules pretty much, okay? Now, once we've done this pretty much, we can combine the right-hand side, this side, into a single logarithm because you can see they have the same base. So we can use that rule if you have log of something minus log of something, you can divide by whatever's in the brackets but have it as a log base 4, okay? So we can rewrite that side as 2 is equal to log 4 of x plus 4 divided by x minus 1, okay? Now that we've gotten to this step here, there's nothing more we can really do without using another log law, okay? We can't solve for x because it's inside the log. So if you recall this rule, a to the q equaling b, you can rewrite that as log a of b equaling q. We can just do the reverse. So obviously you can see in our example here, this represents our a in both of them. This represents our b, this huge algebraic expression, and this represents our power or our q in this expression. So we can rewrite this thing as the following. So we can have our 4 to the power of 2 equaling x plus 4 all over x minus 1, okay? 4 squared is 16, so we have 16 equals x plus 4 over x minus 1, okay? Right, so what we can do now pretty much is multiply both sides by x minus 1, okay? So we have 16 x minus 1 equaling x plus 4, okay? Once we do that, we can then distribute pretty much that 16 on the left-hand side. So we get 16x minus 16. We'll have 16x minus 16 equaling x plus 4. Now you want to combine your x's. So you can see you've got an x here and an x here. So the obvious move is to move this guy to the other side. So what you want to do is subtract x from both sides. Minus x, and that will give you 15x minus 16 equals positive 4. Now you can see you want to pretty much get this number across, so you're going to add 16 to both sides, okay? So this will give you 15x is equal to 4 plus 16, which is 20, okay? Then what we want to do is divide both sides by 15 to get rid of that coefficient there. So we get x is equal to 20 over 15, okay? However, we can still simplify this a little bit more. Both of them are divisible by 5, so you can write the top as 5 times by 4 and the bottom as 5 times by 3. So you can see we can actually cancel out those 5s there. So what we have is x is equal to 4 over 3. Okay. Let's take a look at the next question. If you had any questions about this one here, leave something in the comments and I'll try my best to answer it, okay? So this one's a little bit trickier, but we did a similar one in the last video. So we have 3 bracket log base 2 of x all squared minus 2 equals 5 log 2 of x. Okay, so let's try and solve this guy for x pretty much. So if you want to have a go at this by yourself, feel free to pause the video and I'll let you have a go. Righto, so the trick is with this one is noticing the fact that this is exactly the same as that. Okay, and you have a squared around it. So what we actually have here is a hidden quadratic. So what we can do is let a equal log 2 of x. So we chuck that in there, we get 3a squared minus 2 equals 5 times by 8. So you can see I just chucked this guy in where the log 2 was, and that gave me this result here. Okay, so now we want to move this 5a to the other side, so we get 3a squared minus 5a minus 2 equals 0. So you can see we have a quadratic equation here. Now unfortunately we can't cancel anything out because they're all, well, 2 of them are odd numbers and 1 of them's an even, so there we go, there's nothing there and nothing else is an even other than 1. So what we got to do is we got to write the quadratic formula. So in this case a is equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2a. Okay, so this a I'm referring to is a different type of a. This is referring to the model ax squared plus bx plus c. So that's just the coefficients. This a and that a are not the same thing. That's your variable, but the a I'm talking about here is this coefficient. So what we can do is just say, okay, for the coefficient, that would be this guy here. For this coefficient b, that would be this guy here. And for this coefficient, that would be that guy there. So if we're there was a poor choice of variable being chosen, but that's okay. You can then chuck the b in here, and then the c can finally go in here, okay? So we're going to have a is equal to negative of negative 5 plus or minus the square root of negative 5 squared minus 4 times by 3 times by minus 2. And then divide that by 2 times by 3. Okay, so you can see how I've gotten that because your a is 3, your b is negative 5, and your c is negative 2. Okay, right, so let's try and simplify this huge algebraic mess to get our answers. Okay, now this won't be our answers because remember, we made the substitution that a is equal to, what was it, log base 2 of x. Log base 2 of x. Okay, so the front bit, this can simplify to positive 5. Okay, so you have a equals positive 5 plus or minus the square root of 25. This is going to be, so this bit here would be 12 times by negative 12 times by minus 2 gives you positive 24. Okay, all over 6. So you get a equals 5 plus or minus the square root of 49 on 6. Okay, so we know 49 is 7, so we have a equals 5 plus or minus 7 on 6. So your two answers could be 5 plus 7 on 6 or 5 minus 7 on 6. Okay, so this is going to work out to be, so the top will be 12 over 6, so that gives you 2. this one would be negative 2 on 6, which gives you negative 1/3. Okay. So we then can substitute this guy back in. So we have the following equation: log 2 of x is equal to 2, and we have log 2 of x is equal to negative 1/3. Okay. So now we can use our very first law, which was this one here, and we can rewrite this as 2 to the power of 2 is equal to x, and this one here as 2 to the power of negative 1/3 gives you x. Okay, so this x is equal to 4, and this one x is equal to 1 over the cube root of 2. Okay, so they're both valid solutions for that one there. Okay, if you have any questions about that one there, leave some in the comments and I'll try my best to answer it. Let's take a look at the last one for this video. Okay, so let's try and solve for x this one. So log base 5 of 4x plus log base 5 of x minus 3 equals log base 5 of 7. Okay, so if you want to have a go at this one, feel free to pause the video and have a go, but let's get straight to solving it. So straight away you can combine this side here into a single logarithm, but you've got to multiply what's in the brackets here. Okay, so this can be written as log base 5 of 4x multiplied by x minus 3 equaling log base 5 of 7. Okay, what you want to do next is distribute this to each of the following terms. So you get log base 5 of 4x squared minus 12x equals log base 5 of 7. Okay, now a trick you can do here is, because these are the same logs and there's no pluses or minuses on either side of the equation, this must be equivalent to this. Okay, now you're not dividing by logs, you're just ignoring the operation, making them equal, because you can't divide by log, it's operation. So what you can do is rewrite the following as a new equation. So just go 4x squared minus 12x equals 7. Move the 7 across, so you get this quadratic here. Okay, minus 7 equals 0. Okay, so straight away we want to use the quadratic formula again, and this one we don't have any crazy variables that are the same as our coefficients. So your a, b, and c have to be identified. So your a has to be 4, your b has to be negative 12, and your c has to be negative 7. Okay, so quadratic formula: x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. You're going to chuck this guy into here, you're going to chuck this guy into here, and then finally this guy into here. So you're going to get x is equal to negative of negative 12 plus or minus the square root of negative 12 squared minus 4 times by 4 times by negative 7 all over 2 times by 4. Okay, so let's move this guy out of the corner into here. Let's break them down. So the front bit's going to be positive 12, because negative times negative is positive. So x is equal to 12 plus or minus 12 squared is 144, if I do believe, because I don't have a calculator here, so I have no way to check it. 4 times 4 is 16, so you have negative 16 times by negative 7, so we can ignore those negatives because they'd cancel out. 6 times by 7 is going to be 42, and then 7 times 1 is 7, so the correct answer is going to be, what's that going to be, 112 maybe? Yep, so you have positive 112, okay, all over 8. I'm doing this video unscripted, so the math is real and I've got to get it pretty fast for the video's retention. So 144 plus 112, so that's going to be 6, 5, 2. So 12 plus or minus the square root of 256. Now, I'm not entirely sure if that's a squared number or not. If you give me one moment, I can actually just double check it. So give me one moment, I'm just going to work it out very quickly, because I'm not sure if that actually is a square number or not. I know you guys like cuts and stuff, but yeah, none of that from me. Sorry, mate. No, not that one. Is it 16 times 16? Yes, it is. Okay, so 256 is the same as 16 squared. So that means the square root of 256 is equal to 16. Okay, so we have 12 plus or minus 16 on 8. So that gives you the following: 12 plus 16 on 8, or 12 minus 16 on 8. Okay. So if you add those two together, that's going to give you 28 on 8, and this one's going to give you -4 on 8. Okay. Okay. 28 divided by 8 is going to be equal. What's that going to be equal to? 7 over 2, I think, because 28 is the same as 7 times by 4, and then 8 is the same as 4 times 2, so those cancel out, so that's 7 on 2. This can be written as -1 on 2, and those are your two answers for x. Now only one of them can work because this one's positive, this one's negative, so this one actually isn't a solution because you can't have a negative number. So this is the only solution to this log equation, so x is 7 on 2. Okay. I hope you enjoyed that video. Sorry for being a bit slow on the bottom bit here. I didn't know the square number. But yeah, if you did enjoy, subscribe for more. Okay.